Hi everyone, welcome back to our channel. Today we are going to measure the practical measurement of an unknown capacitance using an shearing bridge. So this is the circuit diagram of shearing bridge. So this is an network consisting of 4 terminals. This is terminal 1, terminal 2, terminal 3 as well as terminal 4. So in the terminal 1 as well as 2, 3, 4, we will give the supply in 1 and 3 terminals and we will connect the galvanometer in 2 and 4. Whenever the voltage V2, okay, so voltage V2 and V4 are same, automatically the galvanometer will give zero deflection. The meaning here is the voltage at second port and the voltage at fourth port should be 0. For example, the voltage at node 2 is 5, the voltage at node 5 is 5, 5 minus 5 is 0. Therefore, current I is equal to V by R. So, automatically 0 by R is nothing but 0. Therefore, the current in the deflector will become 0. So, this circuit diagram we are going to validate with the help of this shearing bridge. So, here we can see the shearing bridge functionality. So, let us try to give the connections for this circuit diagram. Okay. So, initially we have the detector. So, rather than using an headphone, so this is the type of headphone which is used as an detector in the olden days. Since we are updated, we are going to measure the signal with the help of an oscilloscope. Okay, so first let's try to connect the detector to the positive of the detector and negative of the detector. The board itself has an supply. So here we have an AC supply of frequency of 1 kilohertz, which is an signal generator. So from the AC supply we are going to connect the positive of the board, and from the negative of the signal generator we are connecting to the original supply. So here you can see here just we are giving the input. So these are the two, directly we are giving the supply to the signal generator and we just connected the detector. Okay, now let us try to connect the unknown. So this is an unknown capacitor 1, unknown capacitor 2, unknown capacitor 3 as well as unknown capacitor 4. So these 4 unknown capacitors we are going to measure with the help of an shearing bridge. That's what the practical experimentation of measurement of unknown capacitor. Now this unknown capacitor, so connect the one end of the capacitor to the unknown value and connect the another end of the capacitor to the unknown value here. Therefore the connection diagrams are very clear. So this is how to give the connection diagrams for the shearing bridge. So now you have to keep initially CR1 on position and give the supply to the shearing bridge. As soon as you give the supply, so the procedure of starting here is, so here we are going to have the bridge network. In this bridge network, so first initially we have to set the value of, we have to create the disturbance in R2. So therefore initial R1 will be in 0. I am creating some disturbance as some 100 ohms. So this is the disturbance what I am keeping, and the value of C2. So the value of C2 what is shown here also, initially I am keeping in 0 farad, and the value of R4 also I am keeping in 0 position. Okay, so now we can see here, see the signal generator, I mean the output, the detector is connected to the CRO. So you will be getting the signal like this, which has an magnitude like this. Okay, so this is the magnitude of the signal. Okay, let's try to have more time, we can understand it better. So this is the magnitude of the signal. This magnitude is available due to the disturbance is created. Now by varying the value of R2, you should nullify the magnitude of the signal. So now slowly I am introducing 1 ohm. You can see how the signal is generated in the CRO. Now it is 1 ohm, sorry, 20 ohm, 30 ohm, 40 ohm. Since I am increasing the resistance, you can see here the magnitude of the signal gets decreased. Okay, so by increasing 90 as well as now it is 100 ohm, we can see here almost all by 100 it has came to 0. Okay, so again I am trying to increasing the resistance. If I increase the resistance one more 100, automatically the signal is enhanced, therefore I should reduce. So based on this you can take a decision which value to be adjusted. Therefore you can see here the signal is of 0, and you can see here still it has some sort of disturbance. Now perfectly it is an 0. So now what completed here is the voltage across these two terminals, we supply the voltage. Now the voltage across these two is balanced. Automatically the deflector is saying that I don't have any magnitude of voltage, therefore the bridge is balanced. How to write down the values is, so the formula to find the unknown capacitance is given here. So we are going to find out the dissipation factor as, so d is equal to omega. Omega is nothing but 2 pi f. F is nothing but 50 Hz, and C is the capacitance and R is the resistance what you have been obtained. So by using this we can calculate the dissipation factor, and you can calculate the unknown capacitance. Okay, so the formula for unknown capacitance C is equal to C1 into R2 divided by R1. So already C1 value is known to us. Just substitute the values of R1. R1 value is already known. R1 is of 100 ohm, and R2. R2 is connected to, so this is 10 into 10 is nothing but 100, and the value of C1 is 0 point, is already fixed, 0.0 microfarad. Then you are going to get the value of unknown capacitance. After solving, you are going to get the unknown capacitance is 0.01 microfarad. Okay, so that is how to measure the unknown capacitance. So these are the values of R1, R2, C1 from the given. Okay, so therefore, you are going to get the value of dissipation factor and unknown capacitance C1. Same, just you replace in the second port. So again, you have to bring to the initial condition this R2 value. Only R2 we need to adjust. Now R2 is in initial condition, and already we had given the disturbance. You can see here in the CRO, the signal is having amplitude. That amplitude you have to make 0 by adjusting the resistor R2. Slowly I will be adjusting, just observe. So now I am adjusting the dial R2, you can see the magnitude how it becomes 0. So this is 30, 40, 50, 60, 70. You can observe in the CRO the magnitude gets slowly decreased. So still at 100 also it is unable to decrease. Now we have to add one more resistance. So in this fashion, okay. So now it is 200. Now we can see here. So this is 100 and previous is 100. The bridge is balanced. When you substitute, then you are going to get the capacitance as 0.02 microfarad. Okay. So by substituting R1 is equal to 100 ohms and R2 is equal to 200 ohms. So here you are going to get the value of C is equal to, so C1 value is 0.01 microfarad multiplied with R1 value from the, you can see from the dial. So this is 100 ohms. R2 value is 10 into 100, 10 into 10 100 plus 100 into 1 200. So when you substitute it here, automatically this is nothing but 0.02 microfarad. This is how to identify the unknown capacitance or the measurement of unknown capacitance using an bridge called as Schering bridge. So the latest technique to understand this signal, we are using an cathode ray oscilloscope to measure the signal. Now it is saying that the signal is of 0. Signal is 0 means voltage magnitude is 0, indirectly current is 0. If current is 0, indirectly the bridge is balanced. That is what the condition of bridge balancing or the procedure of balancing. So theoretical calculation will be left in the court about how to measure the unknown capacitance using an Schering bridge. There are a lot of methods to measure the unknown capacitance. So this is what the practical experimentation part, how to measure the unknown capacitance. So here you no need to check only for these two capacitors, you can actually measure it by using an decade capacitance box. Okay, so you can see here, so initially keep all the capacitance in 0 position, and now you introduce a capacitance of 0.2. So 2 into 0.2, which is 0.2 microfarad. So already we connected to 0.2, just you connect to this decade capacitance box. Again you can see here this is balanced. Okay, so now when you, this why I'm checking is this to make you a clear that the known, what is the, this is already known here. So the known value is 0.02 microfarad. So after calculating also we are getting the same value, which is 0.02 microfarad. So indirectly the concept here is we are measuring an unknown capacitance. So this is known. We here will get a clarity that exact the procedure what we have done is correct. So the known value is from the decade box is 0.02 microfarad. From the calculation, from the experimentation part also we got same. So based on this we can prove that we are finding an unknown capacitance by using an Schering bridge. Hope you are able to enjoy the video. We will try to do the measurement of unknown capacitance in the upcoming video. Thank you for watching. We will meet in the another video.